So the aim of this is try and show how I'm going to convert between an improper fraction and a mixed fraction. Now, if we remember, an improper fraction is one where the numerator, top number, is bigger than the denominator, the bottom number. So what it means is you've got more parts than actually makes up a whole. So it means you can actually have more wholes altogether. So what do I mean by that? Well, let's take this idea. I'm going to give us an improper fraction. This improper fraction is going to be 5 halves. So what we know on this one is straight away that this is 5 halves, which are going to make up whatever we've got. So now if I'm counting up in my number line, I'd be going 1 half, 2 halves, 3 halves, 4 halves, 5 halves, and so on, which doesn't really help. So what I do instead is I make my bar models. And what I'm going to do here, I'm going to colour in 2 halves. 1 half, 1 half. So this tells me that I've got 1 half plus 1 half, which is going to be 2 halves, and we know that this is going to equal 1 whole. We move on to our next bar model, because of course I've still got halves to add on. I've got 1 half and 1 half again, which makes 2 halves, which is going to equal another whole. Now if we think about these numbers we've got here, we've got 1, 2, 3, 4 halves. Well, I've got 5 halves that I needed in total. So now all of a sudden I've got my next one. And 1 half. So we can see that in this case, 1 half, and of course that's going to equal 1 half. So 1 half, 2 halves, 3 halves, 4 halves, 5 halves. 2 halves make 1 whole, 2 halves make 1 whole, 2 wholes to make 2, and 1 half left over. So this is telling me straight away that my answer for this is going to be 2 whole bar models and 1 half. So 2.5. Now, the other method that I can use for this isn't using our bar models. What it's going to be doing is it's going to be using our knowledge of multiples and factors and things like that. So let's have a little look at this one. And basically, this is just a slightly more efficient method of doing it. Now, if we have a look at this, we know that our denominator is 2. So everything that we're going to work with is going to be in 2 equal parts. It's going to be in halves. And of course, I've got 5 of these equal parts. Well, 2 of them put together is going to equal our whole. So what I'm looking at here is I've got my 2 as my denominator, my 5 as my numerator. Well, how many groups of 2 can I make from this number here? Well, if we think about it, I can get 1 lot of 2, which now means that I've got 1 whole. That means now I'm not going to have 4. Instead, what I'm going to have is I'm not going to have 5. I'm going to take away 2. It gives me 3 halves. Again, can I fit any 2's into there? Well, I can fit another lot of 2. And of course, we know that that now means I've got no longer I've got 3, but I've got 1 left. And of course, 1 half is 1 half. Can't do anything about it. So when we look at this idea of our numerator for an improper fraction, what we're thinking is, how many times can I fit my denominator into it? Well, if we're looking at the number 5, I can fit my denominator of 2 into 5 2 times. 2, 4. I can't fit another one in because that'd be 6, and I've only got 5 parts. So 2, 4, that's 1, 2 whole parts with 1 bit left over. And of course, we know that 1 bit left over is this one here, which is our 1 half. Now, this method works for any fraction. So, for example, we could say that we're looking at the idea of 9 quarters. And again, what we're looking at here is this is my denominator. I have 4. How many groups of 4 can I fit into my numerator? Because remember, every group of 4 numerators makes 1 whole. So in this case, we can say that, well, straight away, I can create myself 4 fours, 4 quarters, equals 1 whole. That's going to leave me now, not with 9 quarters, because I've used 4 of them. It's going to leave me with 5 quarters. And again, we remember that we're looking for groups of 4, and we're looking for how many groups of 4 can we make out of 3. Well, in this case, I can make 1 more group of 4. 4 quarters equals 1 whole. So now we can see here we've got 1 whole and another 1 whole. So So far we've managed to create 2 holes. However, I've still got something left, and in this case I've taken 4 of these away to give me 1/4. How many groups of 4 can I make? Well, I can't make any, so it means that I'm going to be left with 1/4 being left here. So what we've now got is that idea of 1 hole, and 1/4, or 2 holes and 1/4, 2 and 1/4. So let's try another one. Let's try this time on thirds, and let's give ourselves a nice big number. So let's give ourselves 11 thirds. And again, we're now looking at how many of these can I fit into my numerator, because we know that 1 whole is made up of 3 equal parts. 3/3 is 1 whole. Well, how many 3/3 can I make out of 11? Well, if we think about it, we can simply use our mental maths here and do our times tables. Well, I can fit 1 lot of 3. I can fit another lot of 3. I can fit another lot of 3. I can't fit another lot of 3. So that tells me straight away I've got 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3. I've got 1 whole bar, 2 whole bars, 3 whole bars. So 9/3 are going to make 3. How many am I left over with? Well, I've got my numerator now, which is going to be 11. I'm going to subtract that 9 that I've used, which is going to give me this answer of 2. So that tells me what I've got left is now 2/3. So I've got my answer of 3 holes and 2/3. So let's leave you with a little question to do. So this is the idea of changing those improper fractions, those fractions where you've got a numerator which is larger than the denominator. So knowing that the amount of parts you have is definitely more than 1 whole. So thinking about sort of a chocolate bar. If we look at this one, we've got 6 halves of a chocolate bar, but you know that you need more than 1 whole chocolate bar to do that, because we know how many halves make a whole. That means we've got extra chocolate bars to be eaten. So what I want you to do now is have a look at these and using that method to find out how many holes we have. So look at your denominator and look at your numerator. How many times can that denominator fit into that numerator? The amount of times that happens is how many holes you have. However, if you have any left over and you can't fit any more groups of that denominator in, then what you're then going to have is, like that very last question, you're going to have a part left over, a fraction. But remember, you've already been told what the denominator is. So give this a go, see how you get on, and think about that strategy. Is this one that you think is going to be an easy one to use? Or do you prefer this method where you're actually making those bars, making that number line, and counting in that fraction? So would you prefer to say 5 halves? Well, I've got 1 half, 2 halves, 3 halves, 4 halves, 5 halves. I can say I've got 1 whole bar, 2 whole bars, and a half bar. Or would you instead be thinking, I've got 5 halves. How many times can the 2 fit into the 5? It can fit in twice. So that means I've got 2 lots of 2 halves, 2 holes. How much is left? 1 half. So I've got 2 and 1 half. So give these questions a try. Then, if you're feeling really confident, create some of your own. See whether someone in your house can actually be challenged with this. Give it a go, and we'll have a little chat about this and see how we get on in our next session.